Hi there. In this initial video, we'll be covering the setup of the turning environment and defining things like the tool table and the specific part models that we're intending to machine using the turning environment of ENCY. So to start with, we're going to be using this max turn 65 with counter spindle machine, and we are going to initially import the tool table. So to do this, we hover the mouse over the tools icon here, and we're going to click on import tools to the project. Now I have this tool table saved here in a folder on my desktop. It's called turningparts.tom, which is the file format for the tool table. And I'm going to click on open now, and we can see here now the tool table window has been opened, and it's got a complete listing of all of the tools that this project will use. So we're going to close this for the moment because we don't need it open right in front of us all the time. The next thing that we're going to do is we're going to import the model of the part, and we're going to set up the workpiece around it. So to do this, we're going to go to the model workspace, and we're going to make sure that the part folder is highlighted, and then click on import. And I've got turningpart.3dm in the same folder on my desktop. So I'll open this, and we can see we've got a fairly simple part here. It's worth noting that this plane here will in fact be threaded, but the CAM software that I worked with didn't support threading inherently, so we'll just have to imagine that until we run the threading operation. Also, whilst this part is currently oriented correctly along its central axis and appropriately placed, if you import a part and you need to set this properly, the way to do so is using the spatial transformation button, and under locate 0 you will want to set this in X to minimum and then Y and Z to middle, so it centralizes the part in the Y and Z axis and sets the 0 point at the base of the minimum of X. So we can click on close on this now, and I'm going to set the view back to top, and we will go back into the machining environment now. And I'll click on top again until we've got the correct rotation and orientation and everything zoomed out. We do also have a zoom extents button here, which probably would have been an easier way to do it, but it's also worth noting that you have that control of rotation and position of the viewport using this navigation cube here. So we've now imported our part, but it appears to be hidden right in the center of our chuck. So before we define any kind of operations, we're going to want to make sure that we've got the part in the right place relative to our chuck, and we're going to want to define the workpiece around it as well. So to define the position, we go to Workpiece Setup under the Setup tab here, and we click on the ellipsis over here, and we can now set the offset of this in Z because it's based on the operation of the part orientation itself, not on the global coordinates. And if I remember correctly, this should be around 175 millimeters. So I'm going to type in 175. And we can see here that gives the lathe just enough to grip on. I think we might need to move it back a little bit. So quite aside from using the numerical data here, we can also grab any one of these handles and position it properly as well. So I'm going to move this back to, actually, let's leave it at 174 for now. What we can do instead is we can increase the overall amount of workpiece material so there's a little bit more for the lathe to grip on. So let's do that. So we'll leave it at 174, we'll click on OK, and now we'll define the workpiece. So we go to the workpiece tab over here in the inspector window, and we click on primitive to generate a new primitive workpiece, and we're going to define this as a cylinder. Now, one of the things that we need to be careful of is the axis that this cylinder is oriented in. We want it to be in X, not Z, otherwise we'll get a cylinder going across the part. And we are going to define the positive and negative axial stock as, let's go with 10 millimeters for that, but I want the outer radial stock to just be 5 millimeters. So to change that, we're going to turn off same stock, and we're going to change this to 5, and then we're going to click on add. And as we can see, we now have this nicely defined piece of material stock, which has got enough for it to grip on the chuck just fine. as well as enough stick out there to be able to clear off everything that's going on. So we're going to close this now. And the next thing that we're going to do is we're going to define closing the chuck jaws onto this workpiece as well, so we can make sure that everything is properly modelled and we have a complete understanding of where the machine is going to be relative to the cutting tools at all times. So we're going to go back into Setup, and we're going to scroll down a little bit, and we can see here we've got the linear physical axes, which allow us to define things like the chuck jaw diameters. So we're going to go for the main chuck jaws here, and we're going to highlight this number, and we're going to scroll down because we want to be able to visually compare where it's going to. Now that's currently set to 50, which is the diameter of this workpiece, and if we pan around we can see that's a perfect fit for what we need. So now we have that defined, we can zoom back out again. Again, should have clicked on the zoom extents button, a worthy mistake to note. And we currently now have our workpiece ready to go, ready for our first operations. So I shall see you in the next video where we start with the facing and the roughing and the grooving operations.